Good morning. Today we are going through Math Packet number 9. Math Packet number 9 is due next week, Friday. Remember, we have it due on a Friday instead of a Tuesday because the Tuesday it should be due is spring break. So we have it due right before spring break. So we're going to go through our pages and make sure we understand how to do the Math Packet pages. A lot of us have been working on this. So if you've done a page, I want you to pay attention so you can check and see, did I do the page correctly? So sometimes when we're, especially with the word problems, when we're looking at word problems, we might say, oh yeah, I got it done. I don't need to pay attention, but we didn't do it the right way. So let's listen to how we break down our word problems. Our first one says, Bob's super ball bounces exactly half the height from which it is dropped. He drops the ball from the top of a building that is 64 meters tall. How high will the ball bounce on its 8th bounce? So we're going to start here, and he drops the ball down. So it's 64 meters when it starts. It bounces up halfway. So that's our first bounce. How high does it bounce?
32 meters.
32. Half of 64 is 32 meters. Then it bounces down and bounces up half. That's our second bounce. If it's half every time, what's our next bounce going to be, Will?
This one's 16.
This one would be 16 meters. Notice how I'm labeling my bounces. I'm labeling my height as I go. You want to go all the way to that 8th bounce. How high up does it go for the 8th bounce? You're going to work it out, but label it as you go. Can we go down into decimals? Yup. So if you need to use a calculator to divide by 2 each time, use your calculator. Label it as you go all the way to the 8th bounce. Anna, I am recording this so you can watch the recording at home and work on your packet. Any questions? Sometimes when we have the word problems, we just need to work it out, and you can do a picture and it makes it easier. Like when we did the elevator problem, you could use the picture of the elevator going up and down, up and down. Use a picture of the ball bouncing. The key thing is to label it. Labeling your pictures. Let's look at our next page. A florist is making identical bouquets from 36 tulips, 27 roses, and 18 lilies. No flowers should be left over. What is the greatest number of identical bouquets that the florist can make? That's our first question. Second question is, how many of each flower will each bouquet contain? So, a bouquet is the group of flowers. So, my body is up there, so your body should be rolled on this side, so you're focused over here. So it's all on how we position ourselves as to where our attention goes. If we position ourselves that way, our attention goes that way. Position yourself this way, so we're ready to pay attention. So if we want to know how many identical bouquets we can get, what is it that we're going to be looking for? Do you know, Tristan? Not a common multiple. You're close. We have 3 numbers here. What does GCF mean, Nolan?
Greatest common.
Are you Nolan?
Greatest common factor.
Greatest common factor. So we want that factor. Remember, factors are the numbers that we multiply together, those factor buddies that we multiply together to get to that number. We want that greatest common factor that they share. So what is the biggest number that we can use to get to 36, we can use to get to 27, we can use to get to 18. We are not answering it out loud. We're not doing the packet together. I'm just helping you figure out how to solve it yourself. So you need to find that number that is the biggest number that we can divide these flowers up into. So it's one number. How many bouquets are we going to have? Where each bouquet is going to have the same number of tulips. And then each bouquet will have the same number of roses, and each bouquet will have the same number of lilies. How can we divide up those numbers, those flowers, so they go evenly? So that's why it has to be a common factor. Factors we can divide them up evenly by. So you need to find how many bouquets there'll be. And then to find out how many of each flower there'll be, that's its factor buddy. So let's say we had 5. I know it's not 5 because these are not multiples of 5, but let's say we had 5 bouquets. In order to know how many tulips would be in there, 5 times what equals 36. So that's how you would figure out how we are not answering it. That's how we know how many tulips there'll be. We need to know how many roses there'll be. Find its factor buddy with how many bouquets we have. And then how many lilies. So you need to find the greatest common factor of all 3 numbers. And then the factor buddy will tell you how many of each flower will be in that bouquet. So I should have all of those numbers for your answer. You should tell me how many bouquets we'll have, and then how many of each flower will be in each bouquet. Zoe. So why my answer makes sense? Oh no, for the answer, you could either write this up here or you could just draw a line like that. Why your answer makes sense? Because it's this number times this number equals 36. This number times this number equals 27. This number times this number equals 18. That first number should all be the same number. Because it's the common factor. So are you on the page that we're on, making sure you did it correctly?
Okay, so
So why your answer makes sense, you're going to put down the equations. Each first number should be the common number, should be the same number. Times what gets us 36? That's how many tulips there'll be. Because there's 36 tulips. So the bouquets times the tulips equals the total number of tulips. Okay, we're going to move on. I will give us work time when we're done going through our packet. So we're moving on. Our next one is our 5-card challenge. We know 5-card challenges. We cannot just say 5 and call it 1 point because we have to do equations, right? You need to use operations. Make an equation. One number is not an equation. So you cannot just put 5 and count it as 1 point. You have to have an operation. Now, find the area of the shaded region. The figure is a square. What do we know about squares? Well, they have all equal sides. We need to round, and then there's a circle that's inside of it. We need to round our answer to the nearest hundredth. So that's the second decimal point, tenths, hundredths. All work must be shown. How do I find the area of a square? The area of the figure is a square. How do I find the area of a square?
You multiply two sides.
The area of a square equals the side squared. Length times width. We're squaring it because it's the same number. Length times width. So you're going to put what that area is right here.
It's centimeters, meters.
He didn't put a unit on there. So if there's no unit listed, you would just write the unit as unit and put a U. So if we're multiplying a unit by a unit, our answer would be unit squared.
That's the answer?
No, that's the measurement for the answer. The measurement for the answer is unit squared. You need a number in there to be the answer. Well,
you're probably going to go.
So that was the area of the whole figure. We want to know just the shaded part. How do I figure out how much is the shaded part? Goodness, there's no numbers with the shaded part. How am I going to figure that out?
Did you do?
What do you think, Peyton?
No,
Mia?
Yeah, the area of the circle.
Okay. Why the area of the circle? That's the white part. So we need to know the white area because we need to subtract the white area out so we are left with the shaded. How do we find the area of a circle? How do we find the area of a circle?
Isn't it pi?
You're right, it does start with pi.
It's like it's pi something. Isn't it pi times 3.29? Or it's something like that.
Pi is 3.14. So that's what pi is. What are we going to multiply pi by?
Times.
Oh,
I totally.
Times the area of the thing. Times the circle.
Find the value.
what is this line right here? From the middle of the circle to the edge, Gabby? The radius. So our area of our circle is pi times the radius squared. So how do I know what my radius is? If I know from here to here, that side is 10. What is my radius, Zoe?
5.
How did you figure it out that it would be 5?
Because it's just
It's half. Because that circle is right in the middle. So it's halfway from the side. So to go from the middle to the side, it's going to be half of 10, which is 5. So you're going to want to do pi, which is 3.14 times 5 squared. What does 5 squared mean? What math are we doing, Anthony?
5 times 5.
5 times 5. So often I have people do 5 times 2. It is not 5 times 2. That square means you're timesing it by itself. So it is 5 times 5. So once, and then that's again going to be units squared. So you need your number. Once we have the area of our figure and we have our white area, what math do we have to do, Mia? Subtract. We want to take out the white circle so we're left with just the shaded, which again will be units squared.
So we just have to subtract it by the area?
So you find the area of the full figure, you subtract out the area of the white, and you're left with just the shaded area.
Do we have to do the high?
Well, how you found it is the math. You have to show your work. You can't just write down answers without writing out your equations. Write out your equations, and that'll be how you found it. Or you could use your words and say, I found the area of the square, I subtracted out the area of the circle, and I was left with the area of the shaded. But you do have to put something there. So either showing the equations that you did or writing out in sentences the equations that you did. Well, what's the area of the figure? The whole figure goes up top, the area of the white circle, and then we subtract them. Okay, the next one that I have, remember the packet that I gave you, that first page you got was all black. So I stapled the color one at the very back. So turn to the very back. Turn to the colored page at the back. For Math 6, we need to complete the table for the total blocks in each figure. So we need to do this column. So if you are one of my friends who are up for a challenge, complete the whole table.
I just do that.
I do too, because it helps me. I just automatically look at the whole table. So we're going to look at that whole table because it does help us. How many green squares are in my first figure, Tristan? One. How many purple squares are in that first figure, Gregory? 8. So if we have 1 green and 8 purple, how many are there total? Tristan? 9. So you could find that 9 just by counting all of the squares, or you could separate it into the green and the purple. Let's look at figure 2. How many green squares are there, Mia?
4.
How many purple squares are there, Aiden?
32.
So how many total squares are there, Tristan?
36.
36. Look at figure number 3. How many green squares are there, Peyton?
9.
How many purple squares are there, Nolan?
This could be a sack. 1, 2, 3. 12, 13, 14, 16, 17, 18. Oh, I'm already putting track.
All right, help him out, Aiden.
72.
72. So, do you know what I do to make it easier? So I'm not doing that much math or that much counting, because it is easy with these tiny little squares to get confused. I count how many there are going across. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I counted down. 1, 2, 3, 4, 5, 6, 7, 8, 9.
9 times
9 times 9 is 81. And I subtracted out my green. 81 minus 9 gave me the 72. It was a lot easier than trying to count every single square, because then you get lost. Your eyes kind of go squirrely on you. So if we look at our next one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Knowing what we know from these other ones, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. We had 6 and 6, 9 and 9. Here's 3 and 3. If it is 12 going across here, how many are going to be going down? 12. Because it's making squares. What is 12 times 12? Man? 144. I can easily count my green. There are 16 green. 144 minus the 16 green gives me 128. Now, I just heard my friend up front here say, ooh, what's the pattern? Oh. This pattern, it's one of my favorite kind of patterns because it deals with my favorite kind of numbers. What are my favorite kind of numbers, Gabby? Perfect squares. Yep, it's those square numbers. So remember, square numbers are the numbers where you multiply it by itself. So I'm looking at this and I say, well, for my green, 1 squared is 1. 2 squared is 4. 3 squared is 9. 4, my figure 4 squared is 16. What do you think I'm going to do for figure 5? 5 squared. So what my rule is my number squared. So I could say, hey, I can find out how many green they're going to be in the 75th figure without having to draw 75 figures. I know that there's going to be 75 squared greens in the 75th figure. So now let's look at our purple. N is the figure number. So N is the figure number. Let's look at purple. Not quite so easy with my squares. I'm going to look at my perfect squares and say, is there something that I'm doing to the perfect squares each time? Thinking about those functions. What am I multiplying them by?
The square by like 6.
Well, 16 times 2 is not 128.
16 times 4.
Nope. Good guess. 1 times what gives me 8? 8. 4 times what gets me 32?
Oh, you're multiplying it by 8 every time.
So I'm doing my n squared, and I'm timesing it by 8 each time. Look at that. That is a pretty fun rule.
You just times it by 8?
The square. You have to times the square by 8 to get how many purples there are going to be. Now let's look at my total blocks. 9, 36, 81, 144.
They're both they're still perfect squares.
They are still perfect squares. 9 is 3 squared. What is 36?
4 squared.
No, that would be 16.
It's
6 times 6 is 36.
next one 9.
9
Oh, you're
squared.
going up by 3 every time.
12, 15,
Hmm.
18.
So I could find a rule for this. So I would know what the 75th figure, how many total blocks there are. We're going up by 3 each time. So it's 3 times n squared. That's my rule. So I can find my 75th figure. But we see our pattern. Do you see the pattern? 3 squared, 6 squared, 9 squared, 12 squared. What is the 5th total blocks? What are we going to be squaring?
15 squared.
15 squared. That is your answer. So find those kind of patterns and you can fill in your numbers easily. Let's look at our next page. So now we are on our formulas page. Now it says Math 6 needs to do 2 of the 7 figures.
Okay.
You might be one of my friends that's up for a challenge. You're like, yeah, I'm doing pretty good with this. I want to try to find some more volumes. So maybe I want to do the pre-algebra and do 3 of the 7. Maybe I want to try to challenge myself and do 4 of the 7. Maybe I want to do 5. Maybe I want to try to do all of them. Ooh. Okay, math can be fun. Challenge yourself. For now, we're going to write down our formulas that get us that volume. They're giving us the volume. our formulas for it. Does anybody know the formula of a rectangular prism?
Length times width times height.
Yeah, length times the width times the height. So remember, we cannot just divide 60 by 3 because there's 3 sides to it that we're doing. Because 60 divided by 3 is 20. But we have to multiply length times width times height. 20 times 20 times 20 is not 60. We are not adding them together.
8,000.
Yeah. We don't want it to be 8,000. We want it to be 60. So we want to be able to multiply 3 numbers together and get 60. So divide 60 by one number. So maybe 60 divided by 2. That gets us 30. Then divide 30 into 2 numbers. And then you would have 3 numbers that if you multiplied it together, you would get 60. Okay. Same thing for my cube. What is the formula for the cube? Justin?
Length times width times height.
Yep. We could say length times width times height, but we want to remember that it's a cube. So all the sides have to be the same. So I like to put side cubed so I remember that it's all the same number because they're cubed. It has to be the same number. You multiply it by itself, multiply by itself again, and you get 27. So you have to think, what number, when I multiply it by itself 3 times, do I get 27? Do you know the triangular prism?
I know it's
Okay, I would say that one. Sides cubed divided by 3.
We're not cubing it. Remember, because it is the volume, we have the height. So we have length. Just like our rectangular prism, we have length times width times height, but it's a triangle. So we're just dividing it by 2. Because 2 triangles, if you put them together, could make a square, make that rectangle. So you divide it by 2. With our pyramid, we have that same length times width times height. But because it's a pyramid, what do you think we have to divide it by? Any guess?
4.
Oh, I know. 3.
3. It's a magic number with pyramids.
Oh.
Mm-hmm. It's what we learned. We've worked with these formulas. We're going to keep working with them, and it's going to start clicking. Now we have our cylinder. Anybody remember how to find the volume of a cylinder? Anthony, do you remember? It's got that circle. So when we're working, who remembers what the area of the circle was? We just did the area of a circle.
Radius.
There is a radius. It's not just the radius. What did we do, Will?
It's pi times radius equals
Pi r squared. And then, because we're doing the volume, it's not just a circle. What else do we have to multiply it by? Height. So for our cone, again, we have our circle. So we have pi r squared. But then because it's a cone, like a pyramid, you've got that height divided by 3. So the cone is like the pyramid. You have to divide it by 3. And our last one for the sphere, it is 4/3 times pi r. That one is cubed because it's a sphere. So remember, for Math 6, you must do 2 of these. First 2 are the easiest. But if we're ready for our challenge, try to do some of the other ones. Okay? Challenge yourself. How many?
before.
Yeah, the circle ones are the harder ones.
Yeah.
Because you're working with pi. And I would say the easiest thing to do is divide pi out instead of multiplying by pi. Divide pi out of the volume, and then you're just left with the radius and the height. Little tricks to help us. Okay, so you're going to be working on finding those answers. Mean, median, and mode. So, at the grocery store, you buy 3 oranges for $1.20 each, 2 bananas for 99 cents each, 4 tomatoes for 75 cents each, and 3 loaves of bread for $2.50 each. Find the mean, median, and mode of the prices for each item purchased. There are 12 items. So that means you're going to want to write out all 12 items in order from least to greatest. So what's my smallest amount that I have listed price-wise? Will?
4 tomatoes.
0.75. And there are 4 of those tomatoes. So I'm going to write 0.75, 0.75, 0.75, 0.75. I'm going to do it 4 times. What's my next price that I'm going to put? Aiden? 0.99. And there are 2 of them. So I'm going to write 0.99 twice. What's my next number? Peyton?
$1.20.
$1.20. And there are 3 of them, so I'm going to put it 3 times. What's my last number, Gregory? $2.50, and there are 3 of them. Now I have my data points. I know how to work with these. I've done mean, median, and mode with a line of data. Mode. What does mode mean? Most. So which number do we see the most of? Median means what? Oh, what does the median mean? Gregory? Middle. Remember, when we have an even number, there are going to be 2 numbers in the middle. Do I put both numbers for the median? What do I do, Will?
Don't you add them and divide them?
I have to find the mean between those 2. So I add the 2 middle numbers together and I divide it by 2. And then to find the mean, you add all 12 numbers up and do what? To find the mean.
Divided by how much numbers?
Divide by how many numbers. So if I'm adding all 12 numbers up, I divide it by 12. The mean means average. What are you confused by? We've done mean, median, and mode
nothing.
before.
It's just, it's not that. It's the answer that I got.
So you're going to want to put your answer to be to the hundredths place. So you're going to have a decimal because we're dealing with money.
I know.
Okay.
It was like 0.59. It was just kind of confusing.
Okay, you might not have gotten the right number then.
Yeah.
So you might want to double check your math. You're going to have time to work on this page. Okay, so we're not going to work on it right now that we have it all set up on how to do the work. Let's look at our last page. Consider the data and answer the questions. Oops. If you want to do it in this blank space, if you want to do it on the back side, if you have a back side of one, you can do that. If you want to do it on a piece of graph paper or a piece of loose leaf and staple it to it, that is fine also. I did mine just on this bottom space here, and that's okay. Please note, it says use correct labeling. So we need to label our graph. So what would a good title for our graph be?
Injuries.
Injuries. So titles go up at the top. What kind of graph do you think I should make?
A bar graph.
Bar graph is probably the easiest. I need to label each side. Going up, what do you think is going to be my label for that side going up?
Amount of injury frequency.
Frequency. What would be a good label for the bottom?
Number.
Injury type. We're taking it right from the table. We're going to take our labels right from the table. So injury type is what is going on the bottom. Now I'm going to actually put stuff on my graph. So going up, I'm going to put my numbers. What number do you think I should start at?
1. 0.
0. 0 would be at the line. And then I'm going to number them going up. How high up should I go?
To 12. Wait, no, to 14. Because that's the highest number. Oh, 20?
No, I don't know.
There are 14 is the biggest number. So that's as high as I need to go.
Yeah, 14.
What should I put on the bottom? Landon?
Bars.
So if on the bottom I want injury type,
Put the injury types.
I put the list of the injuries. So I'm going to put fall, then cut, then burn, back injury, other trauma, and then injury not specified. And what's my final step going to be?
Make the bars.
Make the bars. Okay, but you need to make sure you have all of your labels on it. When you're making a graph, you should have a title. You should have the titles for your lines. You should have your labels. So you need to make sure to make the full complete graph, and then you can put in the bars. With that, we are done going through our packet, and we're going to have time to work on this packet. And if you have any questions, you can come ask me. If you are listening to this at home, we hope you are well, and we hope to see you soon.